Okay, shall we start again? So we're going to talk about object-oriented design because this is such a mysterious process. And when I actually have a theory, I can't prove it, but does everybody remember the statistics about how many projects fail? Right, that's usually the first lecture of Software Engineering 101. Like, the software crisis. Anyways, there are lots of studies that try to measure how many projects fail, how many software engineering IT projects fail. And they all very consistent. So they all generally report more than 50% of all projects failing. Right? It's very common to see figures like 65% of all IT projects fail and higher, right? But if a company has a failing project, they kept trying to keep that a secret, right? Nobody wants to advertise a failing project. Some projects are very big and they fail and it's very embarrassing and it's very public. Does anybody know of any large projects failing? And you guys are probably too young in some ways to remember some of the big failing projects. Does anybody remember the big NHS IT infrastructure failure? That was huge. You can Google that, like £5 billion flushed down the toilet on an NHS IT infrastructure project failure. There are lots of examples. You know, Internet Explorer is probably a good example of a failure, right? Costing billions of pounds. Anyways, most projects fail actually. And my personal theory is that the reason most projects fail is because software design is not really thought about. It's not incorporated into the software design, into the software development process. It's just not incorporated, generally speaking. And another reason, well, that one reason is it's not taught too. I mean, that's why we're going to make some special efforts here to talk about software design, right? And how do we organize the software? Because it's if you have, in your last software engineering class, you had like Hello World, right? That's a typical. When you have a small project, organization is not that important, right? For example, if you have some Post-it notes, if you have one Post-it note and you put it on the wall, you don't need to organize it. But if you have how many Post-it notes, at what point do you start organizing your Post-it notes? If you have 10, probably not. If you have 20, would you start organizing your Post-it notes if you had 20 of them? Maybe, maybe not. You still read them all. If you have 100 of them, do you start organizing them? Probably, yeah. If you had 100 Post-it notes, and I said, oh, where's the Post-it note that has the deadline for the DMS coursework? You know, you're looking around like, oh, I can't find it. And you start to want to organize it. So the point is, when you have a small amount of information, it doesn't need to be organized. But the bigger that amount of information is, the more important the organization becomes. Now, you've heard about some of these software projects being millions of lines of code, right? What if you had 1 million Post-it notes? Do you think you could find one if they weren't organized? You couldn't. You could never find a Post-it note amongst 1 million if they weren't organized, right? And you can think of, this is an organizing principle, and it's organizing information, right? When you walk into a library, that library has to be organized, right? A lot of thought goes into that organization of the library. If you have thousands of books or millions of books, some libraries have millions of books, by the way, you have to think very, very carefully into how it's going to be organized. How is that information going to be organized? And if you don't think about it, then you can't function. You can't have a functional library, right? You can get a degree in library science, right? How to organize all that information. Some libraries, some libraries are so big, if they have 1 million books and you just grab a book and put it in a random location, it might never be found again. Might be lost forever. Just lost forever. Right? You cannot search through 1 million books to find a lost book. It's just not possible. Right? So this is the same idea. We're organizing information. It's a special kind of information. It's source code. So we're thinking about a process to organize source code. That's all it is, conceptually. But it's kind of, I don't know if it's difficult or easy. I think it's easy, personally. But despite the fact that I think it's easy, it fails in a lot of cases. So we're going to be drawing on material from these books, Designing Object-Oriented Software. I actually put a copy of the first book on Moodle, right, if you want to look at this in any more detail if something I said doesn't make sense. So we're addressing some really fundamental questions. I like to start with the questions to get your mind thinking rather than just me saying, here's the way it is, here is the way it is. Some questions that probably you never thought of before, but you're supposed to be thinking about these questions really every single day of your software development life, really, if you're a full-time software developer. How can we go from a specification to a design, right? And how can we go from a design to an implementation? Those are two phases. How do we get from one phase to the next? What a funny question this is. When do you introduce a new class? Anybody already know the answer to that question? I mean, that's a really advanced question, actually. If you know the answer to that, I would be impressed. When should we introduce a new method? Right? That's a really, really fundamental question. Mohammed?
Yeah, for the method, we have new functionality.
That's a good answer. It's a good answer to start with. We're going to go into the details, more details about all of these questions, right? Are there guidelines for writing good classes and good methods? Right? Has anybody talked about that? How do you write a good class, like a good maintainable class, right? A useful class and a useful method. How about this? When you're writing a new method, how do you determine which class it goes into? But if you have a selection of classes to choose from. How big should a class be? Right? I think Pierre does mention that, actually. And how should your classes be organized, right? How are classes and methods organized? So these are really, really fundamental questions, and we're going to talk about all of those. And hopefully by the end you will know the answers to all of those. By the way, sometimes we're going to talk about things that are also questions appearing in job interviews, right? Imagine you're in a job interview and somebody says, when should you introduce a new class? How nervous are you going to be if you get that question in a job interview? Some people could ask that question. It would be a really challenging question, right? But you do get those questions like that during job interviews. They don't just assume that you know, a lot of people don't tell the entire truth on their CVs, right? They might put down some skills that are not really skills. And so everybody that has a job interview has to pass some tests, like some tests, some essentially verbal tests, to make sure that person that they're talking to matches the information on the CV that they're reading. So I will mention sometimes questions that appear commonly in job interviews, just as an added bonus for you guys. Okay, so we're going to start with a really, really fundamental question. What's an object, right? An object is a set of closely related data and methods that operate on that data or services, right? That's my definition. I've looked up the definition of objects. Has anybody tried that? Like, what's the definition of an object? I have. And I didn't find, sometimes a book will not define it. They will just not, they'll talk about object-oriented methodology or something, but they never actually define an object. So I gave it a definition, my own definition. I supplied my own definition. That could easily be a job interview question, by the way. Somebody could definitely ask that question. An object knows what it is. It knows the information about itself or what information it needs. It knows its responsibilities and how to fulfill them. Tasks that other objects request, for example. It plays a role in a bigger system and it knows how to fulfill that role. And it doesn't know anything else, how to do anything else. And it hides information. It hides all the information that it needs to fulfill its role. That's kind of a mouthful, but I'm going to talk about all of these things in more detail. We're sort of right now just getting an overview of the object-oriented design process and the terminology and the thinking before we go into more details. So some of the fundamental concepts associated with objects, and I think you've all heard these terms already. Right, encapsulation, information hiding, message passing. Maybe you haven't seen message passing so much so far. Polymorphism, classes and instances and inheritance. These are all terms associated with object-oriented design. And they're all job interview questions. If you're applying, I'm saying in the case that you apply for a software engineering job, specifically. They're not job interview questions for every job. But it's very possible that at the job interview somebody says, can you tell me what you think encapsulation means, or what is meant by the term encapsulation, right? And that's true about all these terms here. So we're going to use some terminology that you might not be used to in the design part of the module, right? Messages. So you can think of messages as methods, right? A method is a way to send a message from one class to another class, right? An object A sends a message to B, like, do X for me, or what time is it, for example. You can think of that as a question or a request, like, give me the time. Object B does X, which may involve returning results. So that's a message, passing information back and forth. Not very complicated, right? We also have this term behavior. How does an object behave? It's the object behavior is the set of messages that an object contained in the object, right? Or recognized by the object. We use the term behavior to describe that object. A method is a function performed by an object as a result of a valid message. And then signature is similar to a prototype. These terms are very similar, right? A signature is a method name the input parameters and types, and then the values returned. So the first line of a method, right? That's a method signature. And I'm just mentioning all these terms because I'll be using these terms during the next lectures about object-oriented design, or you'll be using them a lot. Classes and instances, one of my favorite slides. I still remember taking this class, by the way, no pun intended. So I did take an object-oriented design module. It was just a module, and that was the whole module. It's just about object-oriented design, which I think is a great thing, by the way. I still remember seeing this and not quite getting it the first time. Has that ever happened to anybody? Where you see something and you don't get it the first time, but then you see it maybe a second time or a third time and it finally clicks? That ever happened to you guys? This is one of those cases where I didn't quite get it the very first time. And by the way, just as a side note, you've probably heard the terms classes and instances before, right? Now you're seeing it again. Does that mean anything? Does that signal anything to you? That's a kind of abstract question. So you're seeing something for the second time, maybe the third time. Does that trigger anything in your brain? Does it activate anything in your brain? I'll give you the answer because I'm feeling nice. It means it's important. So every time you see something, the importance goes up. So if you're seeing it the second time, it means it's important. If you're seeing it the third time, it means it's like really important. So every time you see it, think, oh, I'm seeing this again? Really? This must be important. So we're often using these terms classes and instances, or sometimes classes and objects, right? A system needs many copies of a given kind of object, right? We need to organize objects of the same type or the same kind. It's so funny. I just think it's funny because it's using many words to describe something that's very simple, actually. But the more words you use to describe it, somehow the more complicated it gets. It seems that way. So a class is a set of objects that share the same behavior. Remember, we have that term behavior from the previous slide. It's a generic specification of all such objects, and it's a template that defines those objects. That's what a class is. And then an instance is a member of a class, or the object itself. So what's an example? I don't know why I always use this example, but I just do. If you think of a car, it has 4 wheels, or 4 tires, doesn't matter. In order to create 4 wheels, you need a description of those wheels, right? You probably want to create thousands of those wheels. But if I say to a manufacturer, please produce these 4 wheels, the manufacturer needs a specification of those wheels, right? A written specification or illustrated specification too. That you can think of as a class. That template, it's a template description of a generic wheel, right? And all the wheels will have these characteristics in common. Then when you get back, the 4 wheels, the physical wheels, those are the objects, right? Or the instances of a wheel. That's the difference. So a class is a template or a specification of an object, and then an instance is an actual copy of that, like an actual realization of that. Does that make sense? I hope. It's probably too embarrassing if it doesn't make sense. Anyways, I hope that makes sense. But I can see, it's not difficult to see when this gets confusing and students get confused by this. Here's a typical class hierarchy, and we're going to have a special lecture just on hierarchies. Remember, this is an overview. So a typical class hierarchy, right, involves a parent class, like figure, for example, and then child classes inherit the behavior of the parent classes. Right? Polygon is a special kind of figure. Circle is a special kind of figure. Square is a special kind of polygon. Right? And here's the behavior, draw area location. And then here we have draw area vertices, draw area radius, and area and size. Right? And some of the behavior has been inherited, and there's some usually additional functionality that's added in children. We're going to talk about that in more detail. And so this is the kind of this is what I was talking about, the different phases of software, object-oriented design, right? There's an initial exploration phase, right, which you've never been exposed to before this module, as far as I know, unless you've taken this material already. In the initial exploration phase, you identify objects and classes, their operations and their collaborations. Then there's a so-called detail analysis, and that's building the class hierarchies, maybe the object hierarchies. And then there's another phase called subsystem identification. And this process is generally iterative. So it's not just linear, starting like step 1, step 2, step 3. It's revisiting those phases multiple times. Okay. And there's more than one correct answer. That's one of the fun things about software engineering is you can produce multiple correct designs, and you can produce multiple correct implementations, right? So that's one of the, it's not black and white. Yeah. So in the initial exploration stage, you'd identify multiple possibilities, right? I know this is very abstract at this point, so we're actually going to do some in-class exercises that make this concrete. I know it's abstract, and I know there's a pun there. So given a requirements specification, we start out by identifying candidate classes in the system. So I can give you, you can get a requirement specification written on paper and use that specification to identify candidate classes and objects in your design. Then we identify responsibilities in systems. So those are the methods that those objects use and need, the classes use and need to fulfill their responsibilities or their behavior, and the information they need to accomplish whatever it is they need to accomplish. Yeah. Step 1, step 2, and then step 3 is assign responsibilities to classes. Right? We have a bunch of classes, we have a bunch of methods. We have to start putting the methods in the classes. Right? That's how we're organizing our software. And then we also determine how each object collaborates with other objects to carry out its responsibilities, right? So objects and classes, Gesundheit, generally do not stand in isolation. They work with other objects and other classes. Okay, so put a star on this slide if you have, I don't know if you take notes or something like that, or I'm not sure what students do these days, but back when I was a student, we took notes and we did things. This is a really important slide. So put a star on this or make a mental note. I don't know exactly how you want to remember this, but this is a really important slide. Guidelines for identifying objects. If there's only one thing that you can remember from the design part of the module, this is it. Given a specification, so imagine you get a specification. You got one today, by the way. Anybody know which specification you got today? Besides Sean and Mohammed? Which specification did you get today? Anyone? Nobody knows the answer? The coursework. You got the coursework today. That has a requirement specification in it, doesn't it? Okay, so that's, if you're given a specification, how do you identify objects? Well, here it is. Classes correspond to nouns. Did anybody notice that? That all classes in Java are nouns? Yeah? Anybody know what a noun is? Who knows what a noun is? Besides Sean and Mohammed. Anybody know what a noun is? Is that somebody raising their hand?
Yeah.
What's your name?
Dan.
Dan, what's a noun?
Object word.
It's an object?
Word.
An object word. What's an object word?
Word to describe an object.
Can anybody help Dan out? Did you guys learn what a noun is in grammar school or primary school or whatever? Anybody remember? Wait? Peter.
It's a thing, basically. So it's like a table in there.
That's so funny. Yeah, so, I mean, I don't know what you guys learned here. I did not go to primary school here. You didn't know this. In my school, we learned a noun is a person, place, or thing. That was the definition of a noun. Is that what you guys learned? Okay, yeah. Anyways, so classes correspond to nouns. I put an example here called vertex. I'm using examples from a drawing editor program. A drawing editor program is a program that lets you draw figures like and things like that, illustrations, like Adobe Illustrator, for example. Use singular nouns by default. Right, so if you're going to use a noun as an object, it's singular. Right? Notice vertex is singular. Apple is singular. Right? Methods correspond to verbs. Does anybody remember the definition of a verb from grammar school? Anybody remember? Was anybody paying attention in grammar school besides Sean and Mohammed? Dan?
Action word.
Yes, so you remember that one. Action word, yes. Methods correspond to verbs. So there I have an example, vertex draw. Right, draw is the method, vertex is the object. Identify what the class does. Do not focus on how a class does its job. And there's an exclamation point there, meaning that's really important. And the how, right? Identify the information and the data the class needs to carry out its task. Eliminate redundant classes, and then multiplicity, here's a good one. Multiplicity corresponds to collections. So imagine I have in my software, the wheel example. If I need more than one wheel and I want to put them together like a set of 4, I would never create a class called wheels. Not a good idea. You'd have, the class name would be something like wheel collection or wheel manager, maybe wheel array, or something like that. It's going to be more, you want it to be more descriptive than just wheels, right? Bad practice. On one of my software engineering jobs, that I have had software engineering jobs in industry, right? So I have industry experience. I remember looking at the source code of this project for the first time, right? Because that happens, right? You get a new job, you want to write some software, and at some point you set up your IDE, you check out the project, right? You download it, you open it up, and you start looking at the source code. Right? That's going to happen for a lot of you. Well, it happens, you know, starting today with this project, this assignment, but it can happen in real life too. I remember at one of my jobs doing this exercise, you know, looking at the source code for the first time, and I could see there were some problems right away. I'm like, oh my gosh, they haven't followed the object and class naming conventions. So not all the classes were nouns, right? That was a problem. Some of the classes were verbs, like save, for example, as a class name, classic mistake. And some of them were breaking the multiplicity rule. Like instead of vertex, they would have a class called like vertexes or something. And they were violating the verbs rule too, methods corresponding to verbs. And then I knew, I could see right away, oh my gosh, these guys don't know about object-oriented design. This project is not designed properly. And I knew I was working on a failing project right within the first few days of starting that job. I'm like, oh, if it doesn't follow the object-oriented design principles, this project's going to fail. So you might, a lot of you might have that experience when you get your first software engineering job. Yeah, so if that happens to you, that's a major red flag that you're on a failing project. Yeah. Okay, stage 2, analysis. Examine classes and responsibilities to find if classes share behavior, right? Can one object or class be made of a child of another? Can both be made a child of a new abstract class? Right? Streamline collaborations, in other words, make them faster and easier and simpler. Examine classes with many collaborations or widespread collaborations. Maybe they have too many responsibilities, and maybe they need to be subdivided or simplified into simpler classes or objects. If a class has no collaborations, maybe it's not even needed. Like these are and this is the analysis phase. This is very abstract, so we're going to be talking about this in more detail. Stage 3 of the design process is identifying subsystems, right? A subsystem is a set of classes that carries out a specific function or that collaborates to fulfill a set of responsibilities. And collaboration amongst a set of classes may imply some sort of a subsystem. And subsystems are a higher level of abstraction than objects. Right? It's a group of objects and a group of responsibilities, and they're all related somehow. Right? Subsystems can simplify the complexity, they can hide complex collaboration, and they can increase the potential for reusability. Right? This is one of the key principles for developing maintainable software, right? Is reusability. If you're writing code that can never be reused, then something's wrong, basically. We'll also be using this so-called client-server methodology, right? The object-oriented model is a client-server model, right? Object collaborations are one way. What does that mean? One object requests services of another object. The client object requests the service, is the object that requests the service. The subject object receives the request and provides a service or returns information. And the interaction is defined by a so-called contract. Right? If I have a program and I ask the time object, like get time, the application that called the time method is the client, and then the time object is the server object. Right? There is a time object in Java, by the way. The client and the server are roles that the objects play, so an object can be a client or it can be a server. So if it's calling in other classes' methods, it's the client. If it's receiving a message from another class, it's the server. And so it can play both roles. The client-server concepts keep track of the relationship between two objects at a specific time. That is why the collaboration is one way. And each object can be part of many different contracts. So another word for contracts is collaborations. Right. Any questions about that? About objects? So if I were to give you a requirement specification right now, could you identify candidate objects from that requirement specification? Do you think you could do that? Who thinks they could do that? Or raise your hand if you think you couldn't do it. Okay, we will have that exercise in class at some point. The sooner the better. If you're really lucky, we'll have it really soon. And the next topic we're going to go into is called class responsibilities. But I think it's 1740. We won't have time to go all through all of this, so maybe we'll just introduce the idea of responsibilities, and then we'll stop, because we won't have time to go through it all. So you can, when you think of objects, at least when I think of objects, I just think nouns, right? When I think of responsibilities, I think of methods. Basically, that's what it comes. That's the simplification. So, objects, classes correspond to nouns. Responsibilities correspond to methods and verbs. That's how I think of it. It's very simple, but it's a very good guideline. So, class responsibilities. What do we mean by responsibility? There are two kinds. There's the knowledge or the information maintained by an object, and the actions an object can perform. Right, the set of methods it has, or the information it needs to carry out those, for the methods to function. And they represent the purpose of an object in the system. So responsibilities define services provided by an object to the system. An information object can return to its client object, or an action object can perform for a client object. By the way, if you wanted to see an example of like a set of objects, where might you go to see examples of objects and classes? If you just wanted to see examples, because I don't have many examples on these slides, right? The slides are pretty abstract. Besides Sean and Mohammed, anybody know where you could find some examples of these things that I'm talking about? No one? Anybody? Dan? Where do you think, Dan? Where would you go if you want to find an example, some example objects in Java? Libraries, which one? Any idea? Anybody help out, Dan? What's your name again? Your voice is very soft.
We can just find these libraries in IntelliJ, and we can just click the class name, and we can go to the source code of this class.
Yeah, that's one answer. Let's try another answer. My machine is not very fast. We can look at the Java API, right? There it is. That's the Java API. It's got millions of examples of objects, right? This is JavaDoc, by the way. This is HTML produced by JavaDoc, one of the tools to use in the coursework. And then look, all classes. You'll notice that they're all nouns, and they all follow those conventions from the guidelines for identifying objects. And you'll notice all the methods are verbs. So if you want to see some examples, this is a good place to look for examples of these principles. But maybe nobody has described the principles in these words before using this kind of methodology, this systematic methodology. Okay, I can see that everybody's getting sleepy, so we're going to stop here and continue next time. Any questions? Okay, we'll stop here then. Yeah.